All right. Okay, I know it's late in the day, and maybe you guys might need a little nap. This is not the place for a nap. We're going to move fast. We're going to have some fun, hopefully show you a bunch of interesting things. And if you don't find them to be interesting, my name is Edson Yanaga. No, I'm kidding. My name is actually Burr, Sutter. Edson actually specifically registered for this event and put the abstract together and everything for me. And when he submitted it, of course, went under his name. But my name is Burr Sutter, so that's who you, if you like the presentation, you can send a tweet to @BurrSutter. If you don't like the presentation, it's @Yanaga. Is that cool? I'm kidding, of course. I do have some T-shirts and some books to give away later. I think what we'll do, though, is we'll let those go as prizes to the winners. I thought originally, bribing you with good ratings for the presentation. If you show me a good rating, I'll give you something. That would be totally uncool, right? But we have a game we're going to play with you guys a little bit later. So you'll need your phone, and you'll have to be ready, and you're going to have to help me test this application, this demo that we've created and set up for you today. For now, we're going to walk you through some slides, show you some other presentations. Just be aware, at the very end there, we're going to actually do something kind of fun. Okay, so again, this is Reactive Microservices with Vertx, Eclipse Vertx. It's an Eclipse project. I work for Red Hat, specifically Red Hat developers. If you go to developers.redhat.com, you can sign up for many things at Red Hat, including downloading of books, and I actually have some of the physical books here for you to actually sample if you would like them. And then you can get all the various Red Hat products that you might be interested in. Of course, like JBoss. I come originally from the JBoss team. 10 years ago, I was part of JBoss when Red Hat acquired us. But we also have things like Red Hat Enterprise Linux there, if you want to check that out as an example. And this presentation's at bit.ly/reactivemsa. That's the next question. Someone says, well, where can I get the slides? That's the URL to the live slide deck, and you can actually follow along with me. It looks like 3 people have already signed into the slide deck. So it's just a Google Doc. All right, so let's get rocking and rolling here. The first thing you should note, at developers.red.com, we do give away books. This is no longer the whole homepage, but there is this Microservices for Java Developers book. It specifically covers Spring Boot, Baldfly Swarm, and Drop Wizard, not Vertx. We've got to work on the Vertx one next. But I do, like I said, have several copies here for our winners a little bit later. Okay, Red Hat actually participates in a lot of open source projects. People know Red Hat for Enterprise Linux. People know Red Hat perhaps for JBoss and application servers. But we do a ton working with the Apache community, the Eclipse community, within the JCP, and numerous other open source projects. This is just a subset of the projects we contribute to. We actually tried to track down the number of projects all our various, thousands of engineers contribute to, and it got to be over 1 million, so we gave up counting at that point. So it's literally hundreds of thousands, beyond 1 million of projects that we work on, and this, like I said, is a subset of them. So one thing I always like to put in my presentations is the concept of the developer evolution. And the way I'd like to think of that is if you're a developer, you've committed to lifelong learning. And more importantly, if you're here at DevOps, you're actually very special. You're one of the elite. You know you've committed to lifelong learning, and you're here to learn, and I really appreciate that. I ran a Java user group for many, many years. I specifically ran my own developer conference for many years, and that's still going strong in Atlanta, Georgia now. And what I really love about these kind of community events is that you guys come together, you come to learn, and you come to grow, and so that's kind of what this part of the presentation is about. Because in the 70s, as software engineers, software developers, we only had to know really 3 technologies: COBOL and either WFL or JCL. And most of you don't know what WFL is, WFL. That was for the Unisys mainframes. My company wasn't wealthy enough to do, like a cool IBM mainframe. We had a Unisys. And some of you don't know what that is. I appreciate that. Some of you do, right? But you only had to know those kind of technologies. Then, of course, in the 80s, we might have picked up C, C++. 4GL technology was super popular in the 80s. We also had this thing called CASE. Remember, computer-aided software engineering was going to cure cancer, feed the hungry. Drag and drop software development, all that stuff that ended up being UML and all that never really worked out. We had things like NetWare. I was a NetWare administrator for a while. I actually set up, LANs. And not everyone knows what NetWare is anymore, I'm sure. But we learned about relational databases, SQL, and we learned about Unix. And we learned about HTML and HTTP in the 90s, get, put, post, and delete. Well, at least get and post. Maybe we didn't figure out the put and delete until well into the 2000s. But, we picked up things like Java and servlets in the late 90s. And maybe you moved to Windows NT, and certainly you'd moved to things like Solaris and AIX. But in the early 2000s, we had to learn even more things as software people, right? MVC, Struts was the king of the MVC world for so long. Spring, DI, dependency injection, ORM, Hibernate, right? Object relational mapping. But we learned a lot of XML in the early 90s because we had to use it for our EJBs originally, if you remember that. But we also did it for all the SOAP and WSDL stuff too. But we then also kind of midway through the 2000s, I should say, is the Agile and Ajax stuff. We kind of figured out Agile, we kind of figured out Ajax. But if you'll notice, the list keeps growing and growing and growing. And that's got to be okay. So even today, as we look at Vertx for the first time and start exploring it, there's going to be a lot of neat things you see, and there's going to be things you're like, I wonder why they did it that way. Because it doesn't work the way Java EE works, okay? It works in a completely different way, and hopefully you'll get a chance to see that and understand that. But of course, if you keep up to date, you're going to be the mythical beast, like the GitHub pink unicorn with the rainbow mane. I love this particular image. I like to use them a lot. But just give you a little context, right? You guys are here because you're always learning. Like I said, you're the elite. Of the approximately 9 to 11 million Java developers on the planet, there's not that many of them in the room today. And as a matter of fact, all the Java user groups and developer conferences I visit, it's a tiny fraction of that universe that gets to come to conferences and visit their local Java user groups. So I encourage you to keep doing that because you always get a chance to keep on learning. Now, this is actually content from Martin Fowler. He basically talks about the fact that you must be this tall in order to take on microservices. They really love harping on this particular item, and I do too, because if you want to be a microservices person, you really ought to do some prerequisites. There should be some stuff that you've already had to do before you go hardcore for microservices. Now, what I've found is I go out and give presentations a lot, and overall, half the people think they're doing microservices already because they've had to because the boss said they were. And you probably think that sounds funny, but I'm not kidding. I literally have found development managers who've already told their people, we are doing microservices here, because they have to convince the business that they're doing the right thing. We also do DevOps here, which is neither which are true, right? But it's actually got to that point where it's so buzzworthy of a word, and think about how much that word's already been used in this conference. That's really the problem we're seeing within that space. But number one on this list is you have to have self-service on-demand elastic infrastructure as code. Here's the test. By show of hands, how many people need at least 2 weeks to get a virtual machine when they request it? Oh, okay, yeah, exactly. How many people need 3 weeks to get a virtual machine or new server when you request it? Still a bunch of you. How many need more than 3 weeks? Okay, still. So this is a great test. I can tell you, even within Red Hat, for our own people, if we need a new virtual machine, it could take weeks, if not months. That is a massive problem for developer productivity. If they need a resource, and keep in mind, developers are not cheap. You guys aren't inexpensive resources. If you have to wait a month to get a resource to then do your job, that's kind of problematic. And so we're seeing this all throughout the industry, and as we go through this concept of digital transformation, we have to solve that problem first. That has got to be problem number one. If you need a resource, you should be able to access an API or a web portal immediately, right? Request that resource and get it within seconds, if not minutes, no tickets required, and your quota will automatically be depleted accordingly, right? They'll keep up with the inventory, the system will keep up with the quota, and you'll be able to get that resource instantly. So keep that in mind. If it takes 2 weeks, 3 weeks, 4 weeks to get a resource, that's a problem. Also, in this concept of dev versus ops, if you want to do DevOps for real and actually bring those two worlds together from a cultural standpoint, there's one thing that has to fundamentally change. You can no longer, as a developer, you can no longer be irresponsible. How about that? You now must be accountable. You must be on the pager yourself. If the system goes down and the users actually call the operator or a help desk first, that's a massive problem. They should call you first. You're the accountable party. It's your bad code that fell over. You fix it. And as a matter of fact, you're the person who specifically put it out there and hosted this thing in this new elastic infrastructure that you acquired in seconds or minutes. Therefore, if you have to restart it, it only takes a few seconds or a few minutes to restart it. But this is the kind of thing you should have to be thinking about in this world of DevOps, okay? So a lot of people talk about DevOps in various ways. I like to think in terms of developer accountability because that's who I speak to, are primarily developers. If you're not working in that world where you have accountability, you have a problem, okay? If you're separated from the business, if you're separated from operations, separated from runtime production through this other set of teams, Massive problem. Automation. So Martin likes talking about Phoenix versus snowflakes, right? So Phoenix servers are servers that you can burn to the ground and they'll rise from the ashes and come right back to life, versus snowflake servers. Servers you SSH into, and you do a little of this and a little of that. And I've been speaking to numerous, like Red Hat customers as an example, and they're like, oh, this is amazing. You know, we can actually update 200 or 300 servers simultaneously whenever there's a new, bugs, critical vulnerability that has to get patched. So if you think about it in this day and age, Linux particular software, right, is under attack all the time now. There's a new CVE that's found like every month of some, a new worm or a new thing that has to get patched. And if you can't get in there and resolve that quickly, you have a problem. Okay? And then let's talk quickly about CI/CD. I love Jez Humble's test about CI, and we'll try this real quick. Let's see if this works for you. So how many people here are doing some form of continuous integration? See, that's like everybody, right? Excellent. Keep your hands up. Leave your hand up if you're doing continuous integration and you follow this golden rule. What's in trunk is always deployable to production. Trunk is always ready for production. Okay, we lost about half of you there. Next rule. And every developer on the project checks into trunk daily. Okay, we got but maybe, okay, we have a handful of you there. Okay, and if trunk breaks, it's all hands on deck. We fix trunk within 10 minutes, even if it's on the weekend. Okay, I think we lost all of you now. So these are the tests like Jez, the guy who wrote the book on continuous delivery, speaks to and likes to talk about. These are the key principles you have to have from a CI standpoint. That's true continuous integration. If you have feature branches that run off for weeks at a time and eventually get integrated back, that's not continuous integration. That's eventually integration, right? And we're not talking about eventual consistency here. We're talking about eventual integration. So you want continuous integration, so keep that in mind. You need to have some form of deployment pipeline. In most cases, large organizations have a pipeline that they can probably sit down on the whiteboard and draw out. That's their level of understanding of the pipeline. Some people have it committed to PowerPoint slides because they're executives, okay? But no one has an automated pipeline, it seems like these days, even though there is the capability within Jenkins now in the Jenkins file to easily craft out a real deployment pipeline without a whole lot of effort. So try to do all these things. You must be this tall. This is in reference to, by the way, for people like me, when I was a little kid and I wanted to get on the ride at the roller coasters, they had a sign that said, you must be this tall to ride this ride, and I was always the kid a little too short. Yeah, so I appreciate this concept of you must be this tall to ride this ride. All right. If you've not read these two books, you must. You must read these two books. The Phoenix Project is absolutely fantastic, and it is written in kind of a parable or kind of a, it's kind of fiction, so it's actually super easy to read. I've actually read it and done an audio book, so this is the kind of book you want to go back to, probably every 6 months or every year. It's a phenomenal book. You need to read it. And then the follow-on book, there's actually several follow-on books. There's, Lean Startup, Lean Enterprise. There's also Continuous Delivery by Jez, and of course Jez and Gene got together and they did this DevOps handbook along with Patrick Roy, the inventor of the DevOps terminology, and then John Willis, famous for his podcast as an example. If you just read the first few chapters of the DevOps handbook, your mind will be blown with the practices and ideas that they're trying to provide you to say, here's how you can do things differently in your shop. Because there's one thing you really have to get your head around from this point forward is we're actually looking for more humane ways to treat software people and operators within the organization so they can build better software faster. And so I really love these two books. I highly recommend them. Okay, so let's talk quickly about what you do as a Java EE developer if you're a Java EE developer today, an enterprise Java developer. You have an operating system. You have a Java virtual machine. You have an application server. And you're all good with that, I'm sure, right? Okay, we'll keep going. You might have an enterprise archive there, an ear. And then you might have a couple wars in your ear, right? And then you might keep jars in there and wars and jars and more jars. And here's the gotcha with all of this. This was great. We did this with J2EE. We did this with Java EE. We got it. Here's the challenge with this architecture. We all have to agree on every aspect of this stack. We have to agree to the same version of the operating system from the same provider, same distribution. We have to agree to the same Java virtual machine and the same patch level of the JVM, because I can tell you I've been burned with a different patch level of the JVM. Still 1.7 point something, but a different patch level, and the software did not work. I don't know if anyone else has seen that problem before, but it can bite you. All right? You have to agree to the same level of the app server for sure, and more importantly, the same configuration of the app server. So we all agree to WebLogic or WebSphere or JBoss or whatever it might be, and we agree to the exact same version, the same patch level, and the same configuration. These things all bite you as you're going to production. And if you want to go to production fast, this is a problem. And so this is the concept of the monolith, right? This is how we refer to it. One real big gotcha is we have to agree to the third-party Maven dependencies that we pulled in from Maven Central. And when we don't agree, we end up with like 60 versions of Spring in production. And this happens to people all the time. And you really start noticing it when you run your own Maven repository and you do some audits. Then you realize what everyone in your organization is doing, and they're using the same, slightly different versions of the same kind of jar files. So just keep this one in mind. This is the real equivalent of the monolith. And of course, you have a big old team supporting it. You might have 18 programmers, 4 business analysts, 2 security compliance people, right, who basically validate that the software is ready to go. You have operators, you have DBAs, because it's not just the programmers. It's all these folks that are involved. This is what DevOps covers. It's everybody. I've had multiple people tell me, well, Burr, DevOps doesn't say security. The security people aren't involved. And of course, if you read the 2 books, they're definitely involved. And the problem is their name is not specified. They feel a little bit jilted. And I told this person, I said, well, why don't they read the book? And he goes, but they don't have time to read. Oh, well, there's the problem right there. When you run out of time to learn, you have a problem. And so that's what we're talking about now. In the case of this monolith, though, you break it up into microservices. This is all well-known information. Break it up, separate into separate teams, the separate little pieces of software that can pick and choose their own stack. But here's the most important thing. They can pick and choose their own OS version. They can pick and choose their own app server and version. They can pick and choose their own software dependencies and software configuration, and therefore they can write their own code. This does allow individual teams to move faster without waiting on the 40 people to actually agree to something. So that's why microservices might enable you to have greater speed, right, when you break these things up. And I purposely made the shapes a certain way and the individuals a certain way. All the same people we saw on the previous slide are still here, just broken up across the different teams, because I get that question a lot too. Does this mean we're laying people off? Of course not. Okay? So here's the key microservices principles. We're going to keep going pretty fast because we have a lot of ground to cover. Number 1 is deployment independence. I cannot pound on that one enough. If you cannot deploy your component with 0 downtime and no negative impact to every other component system, you're not practicing microservices. So this is rule number 1 for microservices in my book. If you have to be able to deploy at any given moment and have no negative impact on the system. If you can't do that, you don't have a microservice. You might have a service in the traditional SOA sense, service-oriented architecture sense, but you don't have a microservice in this new age world. Okay? You should have full independence, redeploy any moment, any time, and with 0 negative impact. Okay? You also want to be organized around business capabilities, right? Typically, you think in terms of siloed user interface people, database people, network people, business logic, back-end people, mid-tier people. You know, we've done that to Java people over the years. Well, I'm just an EJB person. You know how many people used to tell me I'm just a back-end person, I'm just an EJB person? This is years ago at this point. And I used to make funny statements like, well, what is that? So I don't know. Are you kind of like the proctologist? Is that what it is? You just deal with the plumbing? Yeah. Okay, well, I don't know if that's something to be proud of, right? And of course, in this day and age, we want full stack developers. We want people who have cross-cutting skills, which unfortunately for us means we have to learn some JavaScript. But that's just part of the situation in the full stack world. In this case, though, organize around business capabilities, not siloed development silos, right? Not by skill or anything like that. You organize around a business function. What does the business need, and how quickly does that business component need to iterate and get their functionality out the door? Okay, that's how you'll focus. Focus on a product, not a project. This one's actually super critical as well. Most of us as developers work on these long month projects where it might take us 3 months to get to production, or 6 months to get to production, or 12 months to get to production. And often, because it's project-based work and the developer resource is engaged in the middle of that waterfall, in many cases, they might do a lot of scrum and sprints in the middle of the waterfall, water scrum fall. But by the time the fall is happening and the thing is going into production, they've done 3 months of development, now it's 4 months in and they're going to production, the developers are off on a different project. So therefore, if there is a bug as it's moving to production, you got to call that person back, they got to context switch, remember what they did, and then figure out what the bug is. And that's a problem. In a product world, they're on the product all the way to the end. They're on the product when it's in production because they're on the pager, they own it, it's their product. You're the product manager, you're the engineering team, and you own it. You own the SLAs, you own all your happy customers, and you, of course, and the next one here, you guarantee your public API. You're married to your API, and you will ensure that it doesn't break, because if it breaks, you will have a downtime. And I said before, if you want real microservices, you have no downtime ever. Okay? So just got to think all these things in. These are actually very hard tests when you start to think about them. Would you guys agree? Some of these are incredibly hard bars to cover. Smart endpoints and dubbed pipes is one they'd like to talk about at ThoughtWorks specifically, but this is where we don't use that concept of enterprise service bus anymore. You know what happened to us with enterprise service bus? Because, well, it was a great piece of technology, but like all great pieces of technology, you do not want to be in a situation where it's so great that you start to worship it. And this is what happened with the ESB. And I was around for those SOA days. I used to talk about ESBs here at Devox many years ago. Like, you can go look through the archives. It's like 10 years ago or something. And guess what happened? It's like at Stonehenge when all the druids showed up in their cowls and they would sit around and worship the ESB. And they're called the Enterprise Architecture Team, by the way. And everything would have to go through them. Right? Every time they had to prove your standards, what you could use, what tools, what technologies, what frameworks. And of course, you cheated and went around the corners, and they didn't know what was in a POM XML. They didn't understand that, right? So you could kind of skip that. But they tried to roadblock everything, and they did, and that was problematic. So what we're talking about now is smart endpoints, the things at the edge, those microservices, and the thing in the middle is just a pipe. You don't put transformations there. You don't put business logic there. You don't put routing logic there. You don't even have central governance there, and that's what decentralized governance means, and you don't have decentralized data management. So that one, number 7, is the one that breaks the bank for most enterprises. They refuse, because their DBAs are too powerful, to actually split up their database and split up their schemas. And hopefully you saw Edson's presentation earlier where he talked about the journey from monolithic databases to microservices and how you deal with a monolithic database. But that's a deal breaker for most organizations that I've spoken to. The DBAs have too much political power in the organization, and developers, you forget to take your DBAs to beers after work. DBAs are people too. They like beer. I promise you. Or if not, they'll they'll go out for lunch if you ask nicely. And guess what you get out of them? You get your schema changes in a little bit faster. Okay? So we could keep on going here on this stuff for a long time, but I want to keep jumping right in. At the highest level for microservices concerns, right, you have to have some form of load balancing, scaling, and elasticity. You have to have some form of discovery mechanism, resilience mechanism, so that's your circuit breakers and bulkheads. Of course, you have to be married to some form of API. You got to at least address the public API that you're committed to when you produce a microservice. You think through your invocation model. Is it going to be REST? Is it going to be some form of message through a message backbone of some sort? Is it going to be some other mechanism? Because microservices, by the way, is a style. You choose what you want within that style, okay? You want to dress it up or dress it down, you can, and that's the beauty of the style. And so if you want REST, go for it. It doesn't require you to have REST in this world, okay? If you don't like REST, don't use it. Think through your distributed tracing. You got to have some form of way to track a transaction from A to B to C to D, and that's where something like Zipkin comes in. You have to think through your build and deployment pipeline. You have to think through what you want from distributed authentication mechanisms. So we have a project called Keycloak as an example that will help you walk through that scenario where you can actually have an auth token associated with all the different services in the network. You got to think your monitoring, distributed logging, and distributed monitoring. Okay, so these are all just key attributes you have to think through. I want to show you, though, just a real quick demo that I have here to kind of make the point. Let's see if I have it here. So what I have is a simple little hello world just to kind of show you what you can do with a Vertx application. And let's actually do that real quick. Let me find the right window here because I just have this already running. Okay, so this is what a little simple Vertx application looks like. And actually, it's not so simple. It actually grabs the host name of the host it's running on. And the reason I do that is because you'll see that it thinks it's running on a various sets of hosts. Every little service I'll be running here all runs on 8080, all on this laptop. And I have actually at this point probably a dozen different JVMs running right now, all on 8080, because it's all running inside Kubernetes, and Kubernetes is dealing with that port for me. And so let's go ahead and change the code. All right. Let's go here. Bonjour. And all right, Maven clean compile package. All right, hopefully that's nice and visible. Okay, good, fantastic. All right, so we're doing our Maven compile. There it goes. And let's look at a couple things here. Let's do a Docker PS. You can see, actually, I have a lot of Docker instances already running, as I mentioned earlier. But what I want to do now is, actually, let's just do this real quick. Let's do a Docker build. There's a Docker file here, I should have said. All right, there's my Docker file right there in the directory. Docker build, -t, Burr, my Vertx, :v2. Yeah, there we go. Have to make sure I do that right. So there's my Docker build. And of course, with the Docker magic, you basically have wrapped your little application, my little fat jar, my Uber jar, in this nice little Linux image. In this case, I guess we could show you the Docker file real quick. Let's do that. Okay, you can see right there, it's this case it's an Alpine image, but you can use almost anything you want specifically. And I'm running right here on system release. I'm running on a rel VM specifically. But let's do this. Let's do a docker run -it -p 8080:8080, and we're going to do Burr my Vertx v2. If I did that right, it'll pop up the server. There it is, it's deployed, so it actually bootstrapped that whole thing. And actually, let's just go over here and let's look at, this is the one, 80, like that. All right, so it's very tiny, but it's just hello world. So here's the cool thing. With Docker, running something, with getting your stack exactly right, the nice thing about a Docker file is you can specify exactly what base OS you want in the patch level. You can specify exactly what app server you want and exactly how that should be patched, exactly what JVM you want and how that should be patched, and exactly how your configuration, all the data sources, JVM, passwords, things like that you want can all be set up in that Docker file. This allows you to take that package, write like it is from your desktop, if you will, and then move it all the way through the pipeline of production. This is the magic of Docker. It helps you go faster. But there's a challenge with this. If I want to run more of these, right, I could easily do, instead of a -it, I could do a D. All right, so now it's going to run as a daemon. It's running in the background. I do a Docker PS. I got a bunch of things. Let's do a Docker PS grep and my Vertx. Yeah, let's do that. And you can see I have a V1 there and some V2s. So I have a bunch of these Vertx images already running. So just kind of make that a little bit more visual. If I flip over here to the OpenShift web console, stop doing that. It thinks it wants to get giant. There's 3 of these pods running. So Kubernetes calls these a pod. They're just a Docker container. So I have 3 of them running right now. And the cool thing is they'll load balance across all of them for free. I don't have to worry about load balancing. I don't have to worry about service discovery because it gives everybody a DNS name. It updates that dynamically. As soon as one of these things goes away, they all get their new DNS name. So if I come over here and let's just say, let's do this. I think I have these namespaces running. And we did the Docker PS already, but let's see. I actually have one here to show you the get pods. I just have a script, but it's just kubectl get pods right there. And that's the namespace I put them in, kube demo. There's the 3 pods. And if I curl those guys, let's see here. Dun, 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 dun. Let's see. There's the one that's the version 1 that's previously running. Okay, what we want to do now is roll version 2 really into the production environment because I just ran V2 kind of on the fly. And if I want to come over here now and Docker PS grep, you have to remember what you're doing here. Otherwise, this could all get bad fast. I got the V1s, I got the V2s. Let's go there. Docker. Let's do this. Stop. If I got the right one. Yep. I think I grabbed the right ID of that guy. Stop. Okay. Is it that one? That's the one I got, right? Yep, okay. Docker remove. All right, that guy should be gone now. And what we'll do is let's see if we kill them. So V1, there's my 3 V1s, V2 is gone. Fantastic. So what I'm going to do now is I stop that. So again, with a Kubernetes environment, it allows you to manage these things at scale. So I have 3 of the V1s running. I'm going to launch V2 now through Kubernetes. I have that script set up over here. But let's see here. Dun, dun. What we'll do is we'll roll the update. Okay. And we're going to... So this is going to basically, you can see Bonjour is already coming online there. And you can see also what's happening here in the console. But basically, because we're load balanced, we have the service set up. There's 3 Vertexes already running there. It's just a simple REST endpoint. What's happening is Kubernetes is doing a rolling update. It's doing that with zero downtime, right? Basically, the users are still hitting it, and they're seeing it change as it flows. And the cool thing is, if you want to roll that all back, you can. So normally in a presentation like this, we'd spend time talking about blue-green deployments, canary deployments, CI/CD through a canary deployment, but there's no time for that. And actually, James Strachan is talking about that in the other session right now anyway. But this is the kind of concept you would have in a Kubernetes world. This is why I like Kubernetes. It's pretty awesome. This helps me with that zero downtime deployment concept that I mentioned earlier. It helps me with the independence of microservice, and it can take any payload. It could be a Python app. It could have been a Ruby app. It could have been a Java app of any sort. In this case, it's a Vertx app. But to kind of make that point, let's say I want to, let's actually roll it back. Why we have some, we don't watch, we don't need the watcher. We need the updater. All right, so you can see it's pretty straightforward. All I got to do is change to V1. All right. Oh, don't want that. Undo. All right, let's try this again. V2. Yeah, not that one. V2. There. I'd make a comment. All right, let's try this. All right, if I did that right. It's hard typing in front of all you folks. All right, let's roll that update. Should go through its rolling update again. Let's watch it. You can see, okay, there it is. You can see through the console there, it's moving from the original 3 that was load balanced across, now going to the new 3. And what it's displaying here is its host name. Because every one of these JVMs thinks it's running on its own separate server, own separate host. This gives you that flexibility to basically move back and forth between these two worlds. Again, that's kind of a blue-green deployment with canary deployments inside it. The Kubernetes rolling update, that's how it works. But we actually have situations where you truly do a blue-green, all or nothing, cut back and forth, or canary, roll one 10% out. 10% of the users see this, or only certain users see it, and then you decide you can roll it back if you want. But there we're going back to the hello. So that's, when I talk about microservices and the concept of having elastic infrastructure as code and having that ability to do a zero downtime deployment and talk about the independence of each service, this is the kind of stuff that I like to point out and the stuff I like to work with. This, by the way, is just running in a simple a VM here running on my machine. And actually, I have a lot of memory associated with this because I am running a ton of other services here. I have services running in Spring Boot. We have things running in Wildfly Swarm, things running in Vertx, things running in Node.js. They're just in a different part of the demonstration. So there is another dozen things. Oh, Jenkins is running here as well to run my Jenkins files and pipelines. I have a lot of things running in this VM. But you can actually download this thing. It's called the CDK, the Container Development Kit, from developersera.com and try this stuff out for yourself. It gives you a whole OpenShift Kubernetes Docker environment to play around with. Okay? But that kind of hopefully gives you a little context for what I was talking about in the microservices section. Is that good? All right, I told you we're going to go fast. We're down to 29 minutes. Got to keep going here. Let's talk about Vertx. All right, so Vertx is an Eclipse project. I get scolded for not saying that enough. It's an Eclipse project. It was actually born at VMware originally. Tim Fox used to work for us way back in the day. Then he went to VMware and he gave birth to this project. Then he wanted to come back to Red Hat. In which case we said, okay, let's agree to a neutral location for the project, and that's Eclipse. So we do numerous projects at Eclipse. Vertx is one of them. We employ the core engineers for this specific team. I think Julian's here somewhere in the audience, way over yonder. Okay, so if you have really hard questions you want to ask him, or he'll make fun of the answers I give, one or the other. Vertx is a toolkit for building reactive applications on the JVM. So that's kind of an overloaded term, but here's the simple thing. It's a jar file. You throw it on your class path, and you use it. Okay? We use it by putting it in your POM XML. You don't have to put it in POM XML because you might hate Maven. You might want Ant. You might want Make. You can do those too. It's actually incredibly unopinionated. You just basically throw the jar file on your class path and you're ready to rock with Vertx as an example. And what I showed you earlier was just a simple example of a little HTTP listener. We'll go back to that in a second. It's easy to bundle it into your Spring-based application, your Java application, or anything else that you want. And we'll show you more about that in a second. Because at its core, that jar file that I mentioned basically has HTTP and HTTP2, so 1 and 2. Julian's presentation just yesterday, I think it was on HTTP2. But you can listen on HTTP transactions, right? Any kind of traffic coming through HTTP, you can listen on that. You can listen for anything over UDP. You can listen for anything over TCP. And you can basically write your own socket listener to talk to anything. All right? It's just a listener. You just open ports. You just receive streams of data, and you interact with it. That's the easiest way to think of this world, right? Is just I open a port, here comes some stuff, I deal with it. You also have this concept of the event bus and shared data in the core itself. So you'll see an example of the event bus when I do that demonstration, but the idea is simply that it has this ability to share a piece of memory, like in the case of shared data, or messaging across the backplane of all these different nodes, all these different JVMs. This is not traditional enterprise messaging. That's question number one. Oh, does this work like, my IBM MQ series? Hell no. Okay? Not like that at all. It's basically an in-memory clustered message bus that allows you to ship messages from one place to the other. You can actually do pub sub. You can do request reply. You can have a single receiver. You can just pick those different messaging semantics. And the whole purpose of this is as you receive the data, you can move it around the system. Cluster management, by default, it actually uses Hazelcast to actually establish the cluster members. It does not use Hazelcast for sharing the data or for sharing, piping the data through. As a matter of fact, I don't like Hazelcast. I know there's probably someone here from Hazelcast, but it causes me all sorts of problems. And the question we had already from one gentleman that came up just a moment ago was like, that Hazelcast thing doesn't quite work. And we're like, yes, go to Zookeeper. That's the answer. I'll just say that. That's my personal opinion, obviously. It does not reflect necessarily my employer. Probably it does too. I don't know. There's also the web concept. You have the web router. We'll show you some web router stuff, but you have templating. It is a full web stack, right? If you just want to do traditional web applications, which do get, put, post, and delete with server-side templating and shipping HTML to the browser, or rich internet applications or PWAs in this new world, right? You can do that too. So you also have integrations with the Vertx platform, all right? You can then, and keep in mind, these are all optional components. You just stack these on as you need them. If I decide I want to speak Stomp or RabbitMQ or AMQP, I can bring that component in. I can also use multiple languages if I want. By default, I've been showing you Java because that's what I like to work with. I have a Groovy example and Ruby example and JavaScript example later. There's also Ceylon in there also. You can use different languages, and they all have the same APIs because all that's based off the same API within Vertx, and that's kind of cool. Therefore, these guys are all first-class citizens on that event bus. They're all first-class citizens on that shared data. There's even an NPM. If you want a pure V8 Node.js application to be a first-class citizen on that event bus, you can have that too. And there's other support for other runtimes also. There's also a MySQL and Postgres asynchronous database driver. The Mongo one is probably better than most because the Mongo team do a great job with their async database driver. But you have to live in this async world. So just keep in mind that not everything, like, okay, my Oracle database, my DB2 on the mainframe, yeah, that might not quite work. This is an async world we're living in now. Lots of good stuff in here. You're going to see more of this as we go. Again, Vertx is that un-opinionated toolkit for building reactive async applications. All right, so we're all async now. Okay, so just keep that in mind. We're going to keep going here. A quick word on reactive. When we say reactive, a lot of people think, oh, that's like RxJava observables. Sure, that's reactive programming, right? In this case, we're talking about reactive systems, and the reactive manifesto specifically talks about these basic concepts, like being message-driven. So Vertx, by default, is 100% message-driven. All communication is done through some form of communication mechanism. You can make up your own, or we would recommend using the Eventbus. That's what most people use to communicate from A to B to C to D. You can also make REST calls. There's an example I'll show you with REST calls across A, B, C, and D. But message-driven is super critical. This means you don't share classes between different JVMs necessarily. And as a matter of fact, if you use the Eventbus, a recommendation is you always use a JSON payload, even if you think the other guy's a JVM. Because as I said earlier, it might be a V8 Node.js runtime at the other end of that event bus. It could be a Ruby app, a JavaScript app. It's not necessarily a Java-based app. So JSON is the actual payload. Don't send serialized Java objects over there where you didn't have a problem and you lose your independence, right? Because if you send a serialized Java object, they have to have the same class, the same version of the class. If you don't, things break. You want elasticity. So this is able to scale out or scale back. That's super critical in this new world, right? If you can't scale out easily based on load and based on demand, and you can't maintain your responsiveness and your SLAs, you have a problem. You've got to fix that. You've got to ensure that you handle those SLAs. So responsiveness means that we will respond in the time frame that is expected by our customers, by our users, by our individual players, actually. Well, when we play the game with you, you'll see what I mean by responsiveness. Hopefully it all works, assuming the network holds out for us. And of course, you got to be resilient. In case of failure, in case of things getting, so this is where back pressure and things like that come in. But resiliency simply means that if things fail, the whole system doesn't collapse upon itself. All right, you'll see some aspects of that. There's a circuit breaker built into Vertx also. Okay, so on the reactive programming side, so reactive programming is a subset of functional programming. And functional programming, everything's a stream. And reactive programming, you deal a lot with streams. You can just use the callback mechanisms built into Vertx, but you can also use RxJava observables, or you can also use futures. You decide the programming model there from a reactive standpoint. But the reactive programming is on one side of the equation. You also have the concept of reactive systems, as we mentioned earlier. And that's the world like Vertx as a system, or Akka. You probably heard of Akka as well out here in Lightband land, right? They also have a system for this sort of thing. And so by system, we mean it's not just an individual thing that you include within a single application. It is the infrastructure and platform giving you access to all those things you saw earlier, right? I have the event bus, I have the shared data, I have cluster management, I have the ability to do high availability, as an example. Should something fail, the other thing picks up its workload. All that's part of the Vertx ecosystem. Okay? So just keep that in mind. We'll keep on rock and rolling here. All right, so from a vertical standpoint, these are the programs you write. A vertical is a program you write. All right, think of that as your class, right, in the Java land. You're just going to build a program. It's called a vertical. It shares the event bus in the case of a single Vertx instance, which is running within a JVM. I just think in terms of JVM. Okay, that has this one thing called an event loop. The event loop's super critical to understand because you should not block it. And I'll show you an example where I block it just to, where it was funny. I actually sent the code to one member of the team, and they freaked out. They're like, "Oh my God, you blocked it!" I'm like, "I know, I did it on purpose to see if it would break." So that's like a thread.sleep, by the way. So the event loop is a single thread from a JVM standpoint, single thread, and that means every request that comes in gets handled by the event loop and then handed off to a handler right away. So you never have to write any synchronized code. You don't have to do anything, worry about multiple threaded world, okay? So this concept of, the events come in from the browser, from any other source, messages within a queue, other HTTP transactions or TCP transactions coming in, it basically grabs that event, hands it off to your handler, and your handlers do as they will with it. Okay, you're not supposed to block that thread. And so just keep that in mind. You write with this handler metaphor. And if in the case of a multi-core processor, if you have several cores, it basically lights up and sets up an event loop per core. So this is where it goes beyond something like a Node.js, where this idea was really popularized, the concept of the event loop. And in their case, they don't have multi-threading, therefore they only attach to one core. If you have a 4-core processor, you're not really taking full advantage of those other cores. Vertx out of the box looks for the number of cores that you have and basically sets up an event loop for each one. So the first thing is kind of the reactor pattern, right? That concept of the event loop. We refer to this as the multi-reactor pattern. Okay, this is the vertical that we mentioned earlier. You saw this when we did a little demo. It's just a little HTTP. Super simple. Basically, you can see the request coming in here. Whoa, I shouldn't click there. And then, of course, that's the response. You can, of course, stack many responses. I'll show you an example of the router in a second. If you want to get started, you just do the get clone, and then you cd there in Maven package. Again, you don't have to use Maven if you don't want to. But you then have this uber jar that you just say java-jar to run it. It's that hard. Okay, that's how hard it is to get started with your very first vertical as an example. Well, let's talk quickly about the concept of web apps. You have the web server here. Basically, there's a web server built into Vertx. You receive an HTTP request like get, put, post, or delete over that port, right? You have the router that would then interpret that and then send it off to a handler. And I'll show you an example of that code base. The handler then formulates the response, and the response comes back to that user asynchronously, right? Everything's asynchronous in this world, so that's why that's all done to this handler metaphor. And actually, here's the code here I have on the slide, but we'll actually show you this. Let's actually just run this code. Let's see if it'll run for me. While we're here, we might as well run some stuff. Okay, let's see here. Which of these is it? Yeah, this one. Yeah, the font on my screen is so small that it's hard to see everything. So let's do a build and run. And if I've done everything correctly, it'll pop right up. So this is actually a fairly large application. Meaning that it's more of a CRUD style application. Let's go localhost 8080 if I did that right. Okay, assets there. Okay, and in my case, I actually added my Carolina Moonshine. That's not a proper whiskey. I did this, by the way, for the gentleman who wrote this demo application. His name's Clement, and he's very serious about his whiskey. So I did this just to see if he would notice. We'll see if he notices it when he sees the recording. In any case, I can delete that one here. I can come over here and edit one of these guys, and I can just put in some new data, hit save there. It's a full CRUD-style application, so you can do regular web applications. That's the point of this, right? And the code is super simple. And if I come over here, let's see if I have that one open. Whoop, bump, bump. There we go. It is fairly straightforward. There's an example of what we saw in that code earlier. You can see right here. By the way, don't forget the body handler.create. I've done that before. I lost hours of trying to figure out where all my post and put data was actually going. In any case, you have the add one, get one. You can see right here on the get, okay? This is the handler, get one, and there's the ID, the parameter. So that's what it is on the URL for a RESTful style invocation. Here's a post. On this post, I want to add one. So let's go look at the add one. Okay, you can see what it's doing right here. It's JSON decode the value, right? So it's turning that into JSON, what was posted in, and it's basically moving it into a whiskey object, right? It's just a Java POJO in that case, and then it's adding it to a collection that we have, and then it's sending back this response. Okay, fairly straightforward stuff. That's how you would add one. So the programming model here is super simple. I like it because it's not your Java E world. It's certainly not JSF. Right, Java server faces. And it's super cool and super easy. And one thing that should be noted is if you want to just run something like this, you saw what I did. I just ran a script there, but here's hello world again. I can just do Vertx and hello world. Vertx run hello world. There we go. And now I'm running that application. Okay, so you can treat Java as a dynamic language. I love that aspect. I literally would just go hack something up real quick, Vertx run it, and see if it runs. And then, of course, do a compile time. It'll compile it and syntax check it and all that. Let's do here. And let's see, is that it? There it is. So that's the hello world running right there. And then when you're done running it, Control C. Okay, I got to make sure I don't run out of time here. I got a lot of ground to cover, don't I? Okay, but that concept is fairly straightforward. Let's see. Let's jump back slides, make sure we cover all the key items here. Okay, getting started. Dun, dun. We did the router. Okay. All right. The Eventbus, of course, is distributed across multiple VMs. And actually, let's show you the Eventbus. All right, let's show you the Eventbus because I think it's super cool. Right. Here we go. Not that one. All right, that one. Let's run that one. Okay. So that one should be running. Let's see if it comes up correctly. Oh, I have a different browser open at this point. And there it is. Okay. So what's happening is basically we have the HTTPListener setting up, and it basically sets up on the browser. It sets up the Eventbus on the browser. In this case, the browser can also be a first-class citizen listening on the Eventbus. And this means you can certainly push messages to it, but you can actually stream data either way back and forth between the browser and the server. And it takes almost no lines of code to do this. And so this concept is kind of powerful because if I bring other members up in this cluster, like I can bring up another publisher here, let's see here, and I can bring up another consumer here, and let's see if all this will work. Let's just try some stuff, okay? Let's not do that one. Not the bad vertical. Things break with the bad vertical. We try to make a point there. But there we go. Let's see what's happening here. Notice there's now three different messages, 2 different Java messages and a Ruby message streaming out to the browser. And we also have other people communicating back here on the server side. Okay, so you can see there's my there's a publisher and there's a consumer. So this is the magic of the Eventbus. And again, if I open up the code for you real quick, it's very straightforward. Okay, like here's a consumer. Okay, so this is a consumer, JavaScript consumer of that message. Here's a Java publisher of the message. Here's a Ruby publisher of the message. And you can see syntactically they all work basically the same. And they all are first-class citizens on that Eventbus. And again, if we used Node.js, we could do that also. But you can see it's all pumping those messages out now. Okay? So the Eventbus makes these real-time reactive applications super easy. You can actually do incredibly responsive style applications. And one of the things I'll show you as we have a few minutes left is we're going to play this game together. So like I said, have your phone ready. We're going to actually do that. Because I've not actually tested the system properly, and you guys look like you'd be a great test audience. More importantly, I know that if you're coming to DevOps, you've got to bring your best game. Game, get it? Not your A game. I got a game for you. We're going to have a game. So let's do that. So that's an example of the Eventbus. We'll keep marching along, though, because there's more things I want to show you in here. Okay, let's keep going. All right, so let's talk quickly about microservices patterns. Yeah, we should have enough time for this. So the concept of the browser actually making invocations to different services is certainly very powerful, and this is actually very, very common. So specifically from the retail industry, you've probably done this already. You actually have multiple services on the back end that your front end is interacting with, specifically like the pricing engine here. How is the price being determined? The description that you see here, these detailed specifications, the number of reviews we received. One that I particularly like is this in-store pickup, 15 available based on your location. These are individual invocations from the client to the server. The browser, the client is doing the business logic in this case and making calls to the backend server. And sometimes the backend server is actually then calling the mainframe. And you might think, okay, why would anyone do that? But this is actually how a lot of retailers do it. I could speak to a few of them that I met with that do it exactly this way. So just keep that in mind that this might be the pattern you use for microservices. I basically have a series of services that the browser is just invoking individually. Okay, the browser has the aggregation logic. What happens if you fail? You should always think in terms of failure. Okay, watch what happens closely here. When you fail, your store, 15 available, goes away. So you have to have these fallback positions, this business logic that says, if in case of failure, my business logic says, okay, I can't show you how many are available in your local store, but I still know your local store based on your location. You have to have good fallbacks that you have to negotiate with your business to make a decision as to what you do when the component fails, because it will. Especially in a microservices architecture where you have 15, 20, 500 services, some of them are going to be down at any given moment in time. And this is where you leverage things like circuit breakers as an example so you don't also have a cascading fail. The concept of the API gateway, or an edge service as some people refer to it, you move the business logic, the aggregation logic to the server side, and it calls all those different components for you, and it deals with failure at this level, as an example. You might also chain these things together, and this is how Netflix would talk about how they do it. You would actually have maybe 15 of these things chained together. And for those of you who've done enough architecture, you're probably looking at that going, oh my God, that's horrible. What if that breaks? Do we have a cascading failure? This is what you must avoid in this architecture. So when we talk about, having reactive systems, we talk about the reactive manifesto as we did earlier. This is not resilient if you have a cascading failure. So I'd encourage you to think about that. What are your strategies for dealing with any failure in the system? And if you're one of these components, because you're a product, you're one engineering team, you're a two-pizza team responsible for your component, maybe this star, if that pyramid there blows up, I don't blow up, all right? I just deal with it. I suck it up. Right? I eat that failure and ensure that my user, my SLA, is still met. This is why microservices are so hard. Now, I encourage you to think about one other thing. We have just released a blog on developersdirect.com recently about fast-moving monoliths. So basically, we worked with one organization that basically went from it was a bank that went from 3-month deployment cycles to 1-week deployment cycles, all with their monolith. They did all those other things about you must be this tall. They did proper CI/CD. They made developers accountable for the item in production. They incorporated all the other key principles you saw on that list, including things like Kubernetes and Docker images like you saw in the demo earlier. And they now can produce new features every week. That's how fast they go to production. They did that without breaking up the monolith. It's still a monolithic application. Okay, so I encourage you to think about that. The circuit breaker is super simple. If it's closed, we're good, right? And the idea is you have this concept of half open and open. It basically means if you overdraw the circuit like you would in your house, when you plug in your hair dryer and your curling iron and your TV and the portable heater, because this has happened before in my house, not sure if in your house, because it's the middle of winter and everyone decides they're going to dry their hair and also cook something at the same time on the same circuit, in the same socket, with the power bar that's overloaded. And of course, it flips the circuit, you got to run out in the garage in the code or outside or down the basement, and you got to fix that fuse, flip that circuit back. But the purpose is, and you're probably complaining, oh my God, I got to go flip the circuit. But your house didn't burn down. That's the win. Okay? Yes, it's inconvenient that things didn't work, but your house didn't burn down. That's the idea of a circuit breaker, even in software and in this distributed system. So just keep that in mind. And this is what the circuit breaker looks like. And we don't have a lot of time. I won't run the demo, but you can actually, using this example here, right, there's an example I have out there on GitHub. You can actually look through this yourself and get a feel for what that looks like. But I will show you a piece of code that I thought was pertinent when we talk about that. Let's see here. Yeah, there's lots of examples. But you can see circuit breaker options there. But where's my bad one? The bad one's kind of interesting. Yeah, so let's just open this up real quick. And so I'm just using visual code here. But here's bad vertical. The reason I call your attention to this because there's the thread.sleep. That's what you never want to do. Okay? But I did that on purpose so you can show that the thread is just taking too long to respond. Because in a circuit breaker architecture, the more insidious thing is not that the service is down. That's easy. Most of us can deal with catching that exception. Oh, I tried to make a connection. Nothing happened. Service must be down. Try catch. The problem in this world is what if it's slow? And then if it's slow, you are slow. And then everyone who's dependent on you are also slow. And a good circuit breaker architecture deals with slow or dead. And in this case, it does both. And so that's why I slowed it down to show it basically tries to make the call, it waits for the reply, it does all this asynchronously, and it bails if it doesn't actually get a response in an appropriate time frame. Okay, and it calls its fallback. We won't spend time on that because we're going to run out of time. Let's go here, okay? Because we do have a game we want to play. So the microservices demos. Okay, we might have enough minutes to do this. This is going to be the game we're going to play in a second. Actually, let's just spend time on this because this is so fun. If it works. We're going to go high risk here. Okay, so we have set up on a server a Vertx gaming engine, right? So it's just like the Vertx stuff you saw earlier with the Eventbus and everything else, basically. And what it does is has a real-time WebSocket open to your browser. So get out your phone. You're going to need your phone. And what happens is every transaction, every tap on the screen, every button pop is a transaction to the system. Okay, so we drive a lot of transactions really fast. So we go from 0 to fast really quick. It goes to this game engine, all right? The game engine specifically then communicates with a traditional Java EE application, I mean traditional Java application. Well, maybe not so traditional. It runs rules, and the rules engine and JBPM engine specifically calculate the business rules associated with the balloon pop. And it says, oh, you got this many in a row. Oh, you did this many things. Here's your achievements, and here's your calculated score. It also calculates an aggregate score across teams. And then we have these two dashboards that basically show you the team score aggregated as well as the individual achievements in real time. Okay. So here, let me run this for you real quick, just so you probably think I'm messing with you, right? Let's pull these windows up. Let me see, where did my dashboard things go? One of these browser windows. Oh, not that one. Okay. We got to remember which one. All right, here we go. All right, let's see if these guys, sometimes they fall asleep on me. Okay, so we're gonna get here. And I'm just going to play a little bit to show you what's going on here. All right. And boom. Okay. Refresh my browser here. There we go. So you can see, as I pop balloons here, you notice what happens in the background? We already have 15 players involved, 17 players, and already 300 pops are going in. But actually, I can pause you also. Okay, let me refresh this one because this one needs to be refreshed. Let's look on the leaderboard. Look at that. We already have a bunch of people in the system. And let's go here. And let me start the game up again. Okay? So I'm going to pop some more balloons here. And watch what happens. As people get achievements, like if you get 3 in a row, that's being calculated through the BRMS, the rules engine running in that Java application. And go away, Mr. VirtualBox. But basically, you see now what's happening in real time. So as people are playing the game, and these are people in the room playing the game, the URL is demo.burr.red. That's all it is, demo.burr.red. And that'll take you into the client side of this application, this guy right here. And you can basically start clicking away and earning achievements and getting scores and pounding the system like crazy. So you guys are doing a good load test for me. 61 players, 3,000 plus transactions, 4,000 transactions. Each one of those pops is a transaction through the whole system, through the main Vertx game engine, the Vertx achievement engine, and of course that regular Java engine. And Vertx is managing all that traffic for me. And again, I can pause you. That's kind of fun, isn't it? And what's kind of cool, you're probably thinking, oh, this game is way too easy. Okay, let's make them kind of microscopic and super fast, all right? And I'll change the background color to make this a little more interesting. Boom, and let's go. All right, there they go. Now you got those balloons harder to hit? So this is how you deal with the fact that you don't want people to pound your system to death. You just make the game really hard to play. So if I was worried about the actual bandwidth you guys are hitting me on here, I could do that. But what if I want to do this? If I want to make it super easy for you, I can make it, crank up the opacity so it's easier to see, make them bigger, slow it down. Oh, by the way, I want to do 10 points for red, 10 points for blue, 10 points. And let's just change the background again and update configuration in real time there. So everybody sees that, right? So it does take a second sometimes for the ripple out through your little slow 3G connection to get to your actual phone. But now we have 96 players playing concurrently and over 11,000 transactions just in the last few seconds, right, that we've been playing the game together. And, if you don't like that, I can pause you again, okay? So this is an example of when we say reactive real-time kind of style application with Vertx, this is what we mean. This is actually a fairly large little application at this point that we spent a lot of time on last year to build for our keynote demo that we did at Summit this past year. But this gave us an opportunity to really make the point. What can Vertx do for you? Here, if I stretch this out a little bit more, you actually see it's truly keeping up aggregate scores across all those players. All those transactions are being scored, and the different players on different teams are being updated in real time. And of course, you see our leaderboard here. Luck Kitten is still #1 with 21,000 points. He gets a T-shirt. You got to keep that in mind. We do have prizes for you folks. But let's do one more thing here. I'm going to then turn on the golden snitch. All right, this is a 50-pointer. Be ready. All right, let's make it green now just so you get a different background and go. And for those of you who aren't playing in real time, but now it's green, and there it goes to the system. You can be popping balloons. All right, so let me pop in my balloons there. And there's also my face. You can pop my face. But the idea is that you can do an application like this. Now you're thinking, I don't build games. I know you don't build games. But if you can do this sort of thing like this, can you imagine what you could do? You could build your own Google Docs if you wanted. You could build your own Etherpad if you wanted. And I can see one gentleman up there hammering on his phone, trying to catch up. Quick Cat has moved to first place, and Wheat Rabbit We actually give you default names because we learned if we let you enter a name, it can be rather awful. Okay, so we changed that. But you can kind of see how the system's behaving here. We're just, it's doing really well. We're almost out of time. But in just a few minutes, we've been playing the game, 37 transactions into the system, 37,000 transactions into the system with 95 people playing concurrently. So thank you so much for playing along with us here in the audience today, because it does make the demo suck if no one wants to play along. So let's do this. Here's our leaderboard. And go back over here to my admin console. And we're going to say, game over. Okay, and this is what it looks like. Let me bring it up here. Game over. And you notice, there's a few transactions still flowing in because everything is done asynchronously. Yeah. So if you notice, there's a few points still being calculated there because everything is still backed up in those through asynchronous mechanisms and still flowing into the system. So now it's not quite, almost. But Mercury Zebra might pass Wheat Rabbit. There might be enough. There it goes. But that's the idea of a reactive system. So if you see yourself up here in the top 10, it doesn't matter if you're first or 10, right? I have some books, and I have only a few T-shirts, so we'll let the people at the top of the list get a T-shirt if you want, and I have some books for you. But that is kind of what I want to show you. What? Oh, you didn't? But actually, what it is, it does call. Are you Mercury Zebra? Oh, so you never got this transaction to actually stop. We might have a bug. I just hacked this up last week to make it work just in time for you guys, so I might have left something in there that's actually not too good. Okay? But if you need us, feel free to reach out to us at developers@rad.com. The Vertx project is, of course, what we were here to talk about today, and follow me at Twitter at Burr Sutter, but we're out of time. If you have questions, feel free to come up and see me, and if you're on the top leaderboard, come get something. Thank you so much.